This set of videos is to show you how you can make your code more efficient. What I have on the screen here is a diagram of main memory or RAM, and it's showing different storage locations that I've named to use as variables. So I've got 20 different variables here. They've each got their own unique name, price 1, this one's called price 2, and the values of each of these variables are the prices that objects that I've bought, say in a supermarket. So not a long shopping list. I've bought 20 items and the value of this variable is $13.99 and so on and so forth. So if we look at the program to put those values in, I'll just move this out of the way for a minute. So let's look at the program here. I've just declared 4 of the variables for the moment, so I'll just paste that in and let's see it working. So I'm entering the prices, let's say $3.99, I can't remember what the £2.50 and say £6 and £10 for the last one. So it was asking me to enter the prices, and I put the prices into the individual variables, and you won't be surprised that the code at the moment doesn't actually display anything. If I want to display it, I'll put this code back in. So this line here is clearing the field, and then I'm listing the prices with a return character between each one, so they go one after the other. So let's just see that working. So £4, £6, £3, £7, and here are the values in the field. Well, you can see that this is already quite tedious code. Every single variable is declared up at the top. If I want to put in another price, let's just say I copy and paste that, price 5. It's going to take ages just to put the 20 in, and if it was a much longer shopping list, say I had 100 items, I'd be there forever typing the whole thing in. So not a great way to code from the programmer's point of view. There they are. Not a great way to code from the programmer's point of view. It's very time consuming. It's not efficient from that point of view. It's not efficient from a coding point of view. There's the chance for all sorts of errors creeping in here, and all these instructions, before you know it, you're using up a lot of main memory with all these individual instructions. So I'm going to show you a different way of doing the data structures. Let's just go on to here. So at the moment I've got 20 individual data structures, individual variables. A data structure is just a holding place for data. So I've got 20 variables, 20 data structures, and if I bring in this diagram, I'm showing you quite a different, it doesn't look very different, but I've changed it so that instead of 20 individual variables, I've just got one variable that's called price. And it's made up of 20 different parts, and the way I talk about the individual parts is I use these square brackets. And that's common to a lot of programming languages. If you want to have a list of items, if you use these square brackets, you can index into the data structure or into the variable, and the number that you put in the square brackets will indicate which part you're talking about. So the word array is common to a lot of programming languages. Sometimes it's referred to as a list, but it's the same idea, and you always, well, almost always use these square brackets to indicate that type of data structure. So one data structure but with 20 parts. So let's look at the code for that. Well, we'll do that in the next video.